All right, let's get into it. Today, we're going to pull back the curtain on one of the biggest, most important breakthroughs in the history of AI. We're talking about BERT, the model from Google that completely flipped the script on how machines understand human language. But let's start with the core problem, a question that AI researchers were wrestling with for years. How do you get a machine to actually understand a sentence? I don't mean just see the words, but to get the context, the nuance, the relationships between everything. Well, the answer, it turns out, is a story about learning to look in two directions at the same time. So, let's set the stage. Before 2018, pretty much all the advanced AI language models had this one major blind spot. You can think of it like they were all stuck on a one-way street when it came to reading. Okay, so to really get the breakthrough, you have to see the old way of doing things. These older models, they read from left to right, one word after another. So when the AI got to a word, it only had the context of the words that came before it. But the new way, the bidirectional way, totally different. It looks at the entire sentence at once. It uses the words that are coming up just as much as the words it's already seen. And that isn't just a little improvement, that is an AI superpower. You know, this one-way approach was the standard for a long time. Even really powerful early models, like OpenAI's original GPT, were built this way. It meant every word was only understood based on the words that came before it. It's kind of like trying to get the punchline of a joke when you've only heard the setup. You're just missing a huge piece of the puzzle. And this one-way method was a serious roadblock. The researchers who created BERT actually said these limitations were suboptimal and, for certain tasks, even very harmful to the model's performance. This one-way street was putting a hard ceiling on just how smart our AI could really get. But then, in 2018, a paper from researchers at Google AI just smashed right through that ceiling. They introduced a totally new model that finally got AI off that one-way street for good.
I mean, the paper's own abstract just lays it all out there. When they say unlike recent models, they're basically throwing down the gauntlet. And that key phrase, deep bidirectional representations, that's the magic right there. It means the AI gets context from both directions, not just on the surface, but all the way down, through every single layer of its thinking. That was the revolution.
And of course, they gave it this perfect, catchy name, BERT. It stands for Bidirectional Encoder Representations from Transformers. They literally put the breakthrough right there in the name. That B for bidirectional is the whole story. And this was the absolute game changer. Imagine you're trying to solve a crossword puzzle, but you're only allowed to look at the across clues. That's how AI used to work. BERT was the first model that could see both the across and the down clues at the same time for every single word. This just let it build a way deeper, richer, more complete picture of what the language actually meant. So you're probably wondering, how on earth did they do it? How do you train a model to look both ways? I mean, you can't just show it a word and ask it to predict itself, right? That's way too easy. Well, the solution was incredibly clever, and it involved teaching the AI to play two really smart training games. So the first game was basically a super high-tech version of fill-in-the-blanks, something they called a masked language model. The AI would see a sentence, but about 15% of the words were hidden. Its only job was to use the full context from the left and the right to figure out what the missing word was. Then the second game, Next Sentence Prediction, taught it about sentence flow. BERT would be shown two sentences and had to guess if they actually belonged together, or if the second sentence was just totally random. This didn't just teach it words, it taught it how real conversations and paragraphs actually work. But here's where the fill-in-the-blanks game gets even more brilliant. They didn't always hide the word with that obvious mask marker. Yeah, that happened 80% of the time, but for another 10%, they'd swap in a completely random word. And for the last 10%, they'd just leave the original word there, completely untouched. This was such a clever trick. It forced the model to really pay attention to every single word because it never knew which one might be a test or a trick. So, the theory was amazing. The training method was genius. But did it actually work? Well, the answer came when they put BERT up against all the other top AI models on a bunch of standardized language tests. And let me tell you, the results weren't just good, they were absolutely world-changing. And BERT didn't just do well in 1 or 2 areas. It set new state-of-the-art records on 11 different language processing tasks. This wasn't just a small step forward, it was a massive win across the entire field.
So, take the GLU benchmark, for example. You can think of it as like an academic decathlon for AI models, testing all sorts of language skills. The previous champion, OpenAI's GPT, had a score of 75.1. BERT's base model immediately jumped that to almost 80. And the bigger version of BERT blew right past that with an 82.1. In the world of AI benchmarks, that's not just a step forward, that is a gigantic leap. But this is probably the most incredible result of all. It came from a test called SQUAD, where the AI has to read a Wikipedia article and then answer questions about it. Now on this test, the score for average human performance was 91.2. A single BERT model scored 93.2. For the very first time, an AI had officially performed better than an average person on a major reading comprehension test. That was the moment things really changed.
So BERT's success wasn't just some trophy to put on the shelf. It wasn't an endpoint. It was the start of a whole new chapter for AI. It laid a brand new foundation for how we build and train AI that can actually understand us.
And really, the big ideas that BERT proved, that deep bidirectionality and these clever pre-training games, they became the new playbook for AI. This whole concept of creating one super powerful context-aware model that you can then fine-tune for all sorts of different jobs, that changed everything. It's the same design philosophy that led directly to the mind-blowing language AIs we all use today.
And that kind of leaves us with a fascinating thought, right? BERT taught us that learning to see text from left to right and right to left, seeing it both ways, was the key to unlocking a whole new level of understanding. So it really makes you wonder, what's the next context? What's the next dimension that AI needs to learn to see in to really, truly get a handle on our complex world? Thanks for joining us on The Explainer.